we present Spellburst, a node-based interface for exploratory creative coding with natural language prompts. When producing digital artwork, artists are repeatedly translating expressive semantic intents into lines of code. Keep track of different creative variations. And compare, combine, and extend emergent output to further their exploration. Interviews with expert artists helped us understand that existing programming environments don't lend themselves well to this form of creative exploratory process. To address these issues, we introduce Spellburst. Let's see how Merlin, a creative coder, might use Spellburst to generate artwork. Merlin is inspired by the stained glass windows they saw on their recent trip to Spain. Inspired by this, they start with a blank sketch, then write a simple prompt to create stained glass cells with the first modify node. Based on this prompt, Spellburst generates the code for a basic stained glass window template made up of various irregular polygons. Next, Merlin opens up the parameters panel to unveil several dynamic semantic sliders, where the phrase beautiful, intricate is linked to the colors in the sketch. By duplicating the node and creating a new branch, Merlin tries out different color variations of the artwork. Since the original sketch isn't exactly what Merlin wants, they add a modify node that makes the cells look slightly three-dimensional. Next, Merlin opens the code editor and directly adds a stroke weight variable to make the edges thicker. As you can see, Spellburst has automatically added code comments to make the generated code more readable and updates the sketch live as Merlin edits it. Merlin adds one more modify node and prompts to arrange the shapes into a mountain range, shined on by a swirling sun. Merlin then maximizes the sketch to see how it looks at different canvas sizes. Returning to the root, Merlin takes a bigger creative leap, prompting, make the cells move more light, then hit / to bring up Spellburst's divergent autocomplete, which presents three options: jellyfish swimming in the ocean, birds flocking around the mouse, and fireflies flickering in the night. Merlin chooses the jellyfish option, and Spellburst proceeds to make the shapes smooth and move around a blue canvas. Merlin iterates more, prompting first for further refinements in the movement of the jellyfish, and then creates another branch for more fractal and mathematical stained glass cells in a previous branch, producing Sierpinski triangles with the same colors as the previous sketch. They continue to iterate on this new sketch and some previous work through direct editing, playing with the recursion depth. Zooming out, Merlin sees their entire exploration history laid out in the node structure. Looking at the zoomed-out view, Merlin selects the fractal sketch on one branch and the jellyfish sketch on a different branch and executes the merge operation. Merlin prompts Spellburst to grab specific properties from each sketch to have more control over the merge, the fractal shapes from the mathematical sketch, and the smooth jellyfish behavior from the jellyfish sketch. After being inspired by this new visual combination, Merlin performs one final merge operation, combining the shapes and movement from the previous merge with the sun and shadows from the first branch. As seen on the canvas, Spellburst facilitates rapid divergent and convergent iteration through branching and merging. Prompts allow large creative shifts. The semantic sliders transition semantics into code parameters, and direct editing enables fine-grained control. The visual node layout neatly captures the entire creative process so artists can easily explore variations. Spellburst ultimately allows artists to traverse multiple levels of abstraction seamlessly, exploring ideas in various conceptual spaces at once. Artists can focus on ideas and abstract expression rather than technical challenges.